I'm Eric Boehm. I'm curator of aviation here at the Intrepid Sea and Space Museum. And this is Hubble at 25, our 25th anniversary exhibit honoring the Hubble Space Telescope. You're going to see the instruments that are inside Hubble. One of the most important pieces is the CCD chip. This thing has medical uses here on Earth, but makes the Hubble see what it sees and send those images back to Earth. There's also a small section on the biography of Edwin Hubble. Very fascinating guy. He played basketball for the University of Chicago, and we actually have the basketball that he played with when they beat Indiana in 1909. That basketball actually went to space. As many of you know, once Hubble reached space, it failed. So we have a very small section here on the failure. We don't want to dwell on it because Hubble was so successful, but as you can see, Hubble was supposed to see this, ended up seeing that, which made the repair missions all that much more important. Now, Hubble was designed to be repaired in space, and that's kind of like what we focus on, those people stories, because they went up there 5 times to fix Hubble. The astronauts have to learn how to work in space, and the way they do that is in the huge pool, the Neutral Buoyancy Lab down in Houston, Texas. The immersive environment is kind of something where you're not going to get wet, but you're going to go in there and you're going to really see what it feels like to kind of be in that claustrophobic environment working in the pool. 4B, that 5th mission, was really a spectacular mission. So these are the actual tools that flew in space on STS-125 for that final servicing mission. If the light bulb goes out in your refrigerator, you're not going to change the whole refrigerator. So they went up with the intent of actually getting inside the instruments and repairing them up in space. And this was going to be a very novel thing to do because some of these systems were not made to be replaced in space, so special tools had to be built. When you're in the immersive environment, you'll see Mike Massimino working on the Hubble, and he removes a handle. He has to gain access into an instrument, and this handle has to come off. He gets to space, and 3 out of the 4 screws come out easy. The 4th screw gets stripped out. He can't get it out. They tell Mike how much force it's going to take, and Mike just does the brute thing that a guy from New York would do, and he just breaks that thing off and successfully gets inside. And this is the actual handle that Mike broke off in space. This tool was made for this mission. It had to spin at a faster rate than other screw guns because they had to take out a lot more screws than they had to in the past. Here's another tool here. It's a simple laminate roller to install the installation blankets on the Hubble that they were replacing. They needed a laminate roller of sorts, but one for space. And these are tools, once again, not adaptations of tools that we're familiar with, but tools that had to be invented from scratch. One of the things they had to do is they had to get inside an access panel that was never made to be accessed in space. And it had 32 little screws around it. If they took the screws out, they would simply float in space. So they had to design a fastener capture plate. This bolts down over the top of that access plate. Then they can access the screws individually with their screw gun through the little holes in the plastic, back the screw out, and the screw gets trapped between the panel and the plastic. Just an ingenious invention. This is called the ICE-T. This is the index card extraction tool. The ICE-T was made to grab each card individually, pull it out, replace the new card, and then it could be indexed, so you didn't need 4 separate tools to get into the 4 areas. It's actually indexed so that one tool can actually move into the 4 different positions and pull out those cards. These brilliant people, they do that little drawing, a little doodle on a piece of paper to start thinking it out. You're actually seeing the work of an engineer here, direct from brain to pencil to paper. This is one of the very, very, very first drawings of the ICE-T. He actually captured what would become that right on the very first drawing. And that makes this kind of my favorite area of the tool display. And this was taking a look at the Hubble Ultra Deep Field Image and trying to count how many galaxies that we see in our observable universe. First thing I wanted to do was try to describe how tiny that spot of space was. That was the Hubble Ultra Deep Field Image, and that's what happens here. I worked with math teachers actually on staff here at the Intrepid Museum in our education department. What I was able to do with that image is break it up in 1 degree squares, 4,000 1 degree by 1 degree squares. And one of those is approximately the size of the Hubble Ultra Deep Field Image. They actually did break that up into 16 sections. They counted the observable galaxies that they can actually see in the image, and the average that they saw in each one of those 16 squares was 625 individual galaxies in each square. Now 16 times 625 ends up a very clean number, 10,000. So the Hubble Ultra Deep Field Image is looking at 10,000 galaxies. Hubble's not going to last forever. The STS-125 crew actually added a docking ring onto the back end of Hubble because someday Hubble's orbit will decay to the point where it's just going to come back, and we don't want it coming back over New York City or any other populated area. So they someday send up a robotic mission which will attach a retro rocket pack, and then they can control the descent of Hubble. But I would love to see them put that rocket on Hubble and boost its orbit. And in 100 years, maybe we'll have the technology and the wherewithal to go retrieve Hubble and bring her home.